So, quick intro for the video. Going through a couple of cars that I like and just seeing the designs of them and everything. The rear wing, because that is the part of the car that I'm getting to right now with this new project that I'm working on the single seater. I have found a name for the car, by the way. I will announce that in the next video probably. But back to the topic where I'm going with. I'm now in the process of designing the rear wing of the car, and not yet the mechanism and everything, just purely the shape and how it's supposed to look and where the car is supposed to sit. So I'm just scrolling through a couple of pictures of cars, and if you look at, like, let's say a GT3 RS, Porsche, or obviously 911, 991.1 generation version, you can kind of see that the wing is following the contour of the rear of the car. So the midsection is kind of the part that is furthest back on the car. So the wing end plates are closer to the front of the car than the center of the wing is. And also with a bunch of other cars you can kind of see the same thing, because that rear wing is kind of following the same shape of the rear bumper of the car. So that is probably also the reason why they are doing this. But if you look at, like, airplanes, fighter jets, and Lamborghini Countach, for instance, they are using wings that are shaped in the opposite direction. So the center of the wing is more towards the front, and the wing end plates are more towards the back, are the furthest point on the car. So basically, so I wanted to see what the difference between the two is and how they compare in not only error results with CFD and everything, but also just with the overall results, actually, if one produces more downforce than the other one, and all of those things. So I kind of found a way to get to that and to kind of test that in a good way, and I'm very curious to see what the results are and just all of that. So let's get into SolidWorks.
Alright, so now that we got all of this data loaded, I also got the Excel sheet with all of the results and everything. Yeah, I just wanted to take you guys through everything that I did for the wings and everything. So you can already see that there's probably a major difference in the vortexes that are being created for the wings without the wing end plates and the ones with the wing end plates. So you can kind of see the difference in that. And also you can kind of see that for this wing pattern, you can see that the air is kind of being directed towards the center towards the center of the wing. And if you look at it at this one with this shaped rear wing, you can kind of see that the air is being directed more towards the sides. So I think they will also play a pretty vital role in why these the results came back the way they did. So now let's take a look at the results. So these two are the wings that have the curvature that is going towards the back of the car, so the usual car setup. And as you can see in the downforce numbers, they're creating the least amount of downforce. So there are 30 kilograms of the center of the straight wings, basically. So, and that is something that I really didn't expect, because I thought that these would create more downforce because of their increased surface area of the wing. And yeah, that is just something that didn't happen. So I was a little bit dumbfounded by these results until I saw the CFD, and it kind of made a little bit more sense after that. So the one that has a curvature that goes towards the front of the car is also creating less downforce, but it is still creating more downforce than this version right here. So I kind of still need to figure out how that happened and why there is a difference between these two, but we will kind of see it in the CFD, I guess. So another thing is that even though this version with the curvature towards the front of the car and this one have pretty big differences in amounts of downforce that they're producing, their air resistance that they are creating is very similar. So you can kind of see that it is a couple of newtons off, that this one is a little bit it creates a little bit more air resistance than the other one. So that is another thing. And this one does really create the biggest amount of air resistance. So yeah, let's just go over those results, and we'll see what we can find. So of course, as I said, these wing end plates really do something, because you can also really see it here that that air current that is traveling over the wing is trying to get attached towards the bottom section of the car, the bottom surface, and because of that, it's kind of starts this motion, and that creates vortexes and everything. But the other thing that is pretty evident that you can see is that that air that is hitting it on the top is moving towards the center of it. So you can kind of see all of that air move towards the center, and I guess that is also why it maybe is creating the least amount of air resistance, because most of that air is not getting into these vortexes because it is moving towards the center. So you kind of cancel out a lot of those vortexes by doing that. So in this case, you can even see that more profoundly, and in this case, with the curvature going towards the front of the car, you can really see that those air currents are traveling towards those vortexes, so more towards so more towards the vortexes, as I said. So I guess that is also maybe why it is creating a little bit more air resistance, even though they have the same amount of surface area and everything. So that is maybe one of the reasons why. Another thing that kind of caught my attention is that you can kind of see from the top view that these air currents that are traveling here straight kind of move towards the side of the wing, and that kind of increases the path they take, and also at the same time it is stretching out the wing pattern. So where you normally would look at the wing pattern and kind of that it would be this shape, it will kind of get stretched out because of that angle that is the approach angle that it's taking. So that makes the wing a little bit less aggressive, and that kind of it isn't trying to direct the air upward with the same amount of energy as it would in this straight situation with all of those air currents just traveling in a straight direction, if that makes any sense. So I guess that is also maybe one of the bigger reasons why this one is still creating more downforce than these versions right here. So I guess that is basically what is happening right here. So the last thing that I still don't really understand is why this one is creating more downforce than this one. I can't really see that in the CFD results with just the air of the flow and everything. So I still need to figure that out. If you look at the low air pressure zone underneath the wing, you can kind of see this whole complete blue zone right there, and you can also see like the yellow high air pressure zones on top of the wing. And can we see a difference in those right here? You can kind of see that there is a less of a yellowish zone on top of the wing, but yeah, you can really see that this blue zone is significantly bigger than in the other direction. So this under section is probably just more efficient in creating downforce, but why, I can't really explain. So yeah, that maybe later on in my life I actually get an education, and that will become more clear. But so for the car that I'm designing, I will kind of go with a mixture of these 4 wings and kind of just skip this complete design and not look at that, and try to come up with a solution that is creating the as least air resistance as this is, but with the amount of downforce as this one. So that is basically what I'm gonna do right now. So thanks for watching. Please leave a like or subscribe. In the next video I will make a video to announce the name for the project, for the single seater project, and yeah, I hope to see you guys in that video. So thanks for watching yet again, and I'm Veldboom, SVA Design.